as I mentioned, we are going to start in on chapter 2 tonight. And with that, our first section is 2.1, where we're going to look at quadratic functions and then some of their applications. So when we graph quadratic functions, that's really just a parabola, right? And that is where we have ax squared plus bx plus c, where a cannot be equal to 0, because if a was equal to 0, then we would just have bx plus c, and that is a linear equation, not a quadratic, okay? Now, if our parabola opens upwards, that means that our a is greater than 0, and if our a is less than 0, then our parabola is going to open down, okay? And the function in vertex form, this is that function in vertex form right here, and that is that my function is a times x minus h squared plus k, where h and k make up our vertex, okay? Now, one thing I do want to point out to you guys is note that this here is a negative. So if I'm coming along and I see something that is like 2x plus 5 squared plus 3, right? In vertex form, that's really 2x minus negative 5 squared plus 3. So in this case, my h is negative 5 and my k is 3, okay? So my vertex in this case would be negative 5, 3, okay? Now, if I see the negative there, then it's just h, and so then if I had had something like, if I had had 2x minus 5 squared plus 3, then I'm already in my vertex form. So in this case, h is equal to 5 and k is equal to 3. So my vertex would be 5, 3. Okay? Any questions on that? One last thing I'll point out here is that you can see that there's axis of symmetry when x equals h, right? And so wherever our vertex peaks at, you could think of that, if I was to put a line right here, everything on this side is a mirror copy of this side, okay? And that's true whether the parabola opens up or down. Okay, question. Okay, so look at some examples. If we want to graph f of x equals x minus 3 squared minus 9, we could do so. We know that our vertex is, well, first of all, let's look at our h and our k, right? So our h is equal to 3 and our k is equal to negative 9, right? Because we're already in vertex form over there. So in this case, and I can also say that my a, let me do this. So this is like a 1 right here, right? So a is equal to 1, which is greater than 0, right? So that tells me that I open up, okay? And I just want to do that. That is my h, and that is my k, okay? So with all of that information, then I know then that my vertex is my h comma k, and my h is 3 and my k is negative 9. Okay, so I can come to positive 3. That's 1, 2, 3, -9. That is my vertex. I do know that I'm opening up, right? Because my A is greater than 0. I'm not going to put that in just yet. We're going to calculate our X and Y intercepts and then use our axis of symmetry to help us round out the shape of that graph, okay? So the next thing we want to do is if we want to look at our x-intercept. Remember the x-intercept is we just set our equation equal to 0 and solve. So we would say that x minus 3 squared minus 9 is equal to 0. Add 9 to both sides, and we get that x minus 3 squared equals 9. Okay, now we could take the square root of both sides, and we get that x minus 3 equals plus or minus 3, right? Because remember, when we take the square root of something, it's both the positive and the negative. And so now we can add 3 to both sides. So if it's positive 3, that's going to be 3 plus 3, so 6. If it's negative 3, it would be negative 3 plus 3 is 0. So our x is equal to either 6 or 0. Therefore, based on all of this work, our x-intercepts are 0, 0, and 6, 0. So something to point out on the exam, a few of you just said x equals 0. Well, that is not an intercept, right? Let's just say pick the number 6 one. So 6, 0 is this point right here, and that is where our graph crosses the x-axis. If I just put x equals 6, that's this whole entire line. And that is not where it crosses, right? It only crosses in one particular instance, and that is when the y is equal to 0. Okay, so you'll notice on your exam, you probably lost a point there because it is not the whole line. It is, in fact, just one specific point, which is that point right there. Okay, and then our other one is at 0, 0. Okay. Now let's look at our y-intercept. Our y-intercept, remember, that is where we let f of 0. So we really just plug in 0 for all of our x's. And so that would be 0 minus 3 squared minus 9. So negative 3 times negative 3 is 9 minus 0 there. Minus 9 gives me 0. So this tells me that my y-intercept is at 0, 0. We've already plotted that point, and so we can go from there. So we can see that that graph will look something like this. And so we have this line of symmetry right here, right? So you can see that this half of the graph is a carbon copy of this half of the graph. Okay, and so our axis of symmetry is x equal to h or 3. I'll write that here. X equals h equals 3. Okay, question. Okay, let's look at another one. So in this example here, this tells me that a equals -1, which is less than 0. So it's going to open downwards. Okay. This right here tells me that h is equal to 2, because remember, we want that to be a negative right there. And this right here tells me that k is equal to -1. And then knowing all of that, we know then that our vertex is going to be h comma k, which is 2, -1. So we could come over here. Here's 2, here's -1. That's our vertex. Remember, we're opening down, so it's going to be something like that. But let's go ahead and see what that is based on finding our zeros. All right, so let's look for our x-intercept first. So for our x-intercept, we start with our original equation, this negative x minus 2 squared minus 1, set that equal to 0, okay? So we'll add 1 to both sides. That gives me negative x minus 2 squared equals 1. Now let's multiply or divide everything. Let's just multiply the whole thing by -1. So that gives me x minus 2 squared equals -1. And now we can take the square root of that. But the problem is we can't take the square root of a negative because that is undefined, right? So we have no x-intercepts, okay? And that makes sense, right? Because we know this is going to open down looking like this, so it's never going to cross our x-axis. So we confirmed that that is correct. Okay, so for our y-intercept, that is going to be f of 0 equals negative 0 minus 2 squared minus 1. So that's negative 2 times -2 is 4 minus 1. And so when we add those together, we get -5. So our y-intercept is 0, -5. So we could come over here, 0, -1, 2, 3, 4, -5. Remember, we have this axis of symmetry here. So this is a mirror copy of what's on the other side. So we're down 5 and 2 off of the symmetry there. So we could be down 5 over 2 off of the symmetry here as well. And that is what that graph would look like. Question? So the axis of symmetry, it's x equals h equals 2. Okay? Any questions? All right, so now we are going to write, if we're given something in the quadratic form and we're asked to write that in vertex form, well, how do we do that, right? And so we're going to do that by using a technique that's called completing the square, okay? And so I'm going to use multiple colors here to help you because there's a lot of moving parts and it can be a really confusing thing. You can definitely YouTube or Google some extra videos if you want to get extra practice. Khan Academy. KhanAcademy.com has some really good videos if you just want to look at some extra videos. I'm going to write this a little. Academy.com. They have really good, it's a free resource that you have younger siblings or other classes. It is a wide range of free educational videos on everything from like second grade, every topic, maybe not every topic, but all the way up to calculus, physics, chemistry, all of it, okay? All right, so completing the square. So that's what we're going to do here, completing. So if you're looking to say, well, what do I search for, right? But hopefully after we go through a couple of these, you won't need to Google extra resources, and you'll have a good grasp of it. Okay. So what we have here, we want to first rewrite the problem. Okay. So we want to factor out the leading coefficient in front of x. Okay. So we're going to factor that out. So that's going to be 2 times x squared plus 10x, right? Because if I multiply this back together, I get the 2x squared plus 20x. Now, we're going to skip out on this. Let's just skip some space here and then write the 42 outside. We're not going to factor with the 42, okay? We're going to kind of put that outside. We haven't done anything to change it. So right now, as this stands, if I put this all back together, I would get 2x squared plus 20x plus 42, right? Does everybody agree with that? Any confusion? All right, that's step 1. Step 2 is what we're going to consider completing the square with parentheses, okay? Within this parentheses. So how I do this is I take this number right here. This is what we call B, right? Because, right, this was A, B, and C in our quadratic formula, right? So I'm taking the letter B, I'm taking B, and I'm going to divide it by 2 and square it. So I'm taking B divided by 2, and then I'm going to square it, okay? I'm going to just scoot this over here a little bit. And so that would be 10 divided by 2 squared. That equals 10 divided by 2 is 5. 5 squared is 25. Okay? So I'm going to add 25 in here and minus 25 from here, right? Does everybody see that? But I don't want to have both of those in there because it defeats the purpose. So what I'm actually going to do, well, let me put that here just for a moment and I'll show you. But I want to take this one and I want to move it out here because that then leaves me with a perfect square right here, which, remember, vertex form is our vertex form. We have this perfect square here, right? And so that's what we're trying to get to. Okay, so we're going to move that out, but we can't just move the 25 out because, remember, we have to distribute this to everything inside of here to make the problem still the same. So what we're going to bring out is we're going to minus 2 times that 25. Okay? Question. All right, so that leaves me then with 2. Now, when I want this completing the square, this perfect square piece right here, this tells me what my value is. So that is actually 2 times x, that's positive, so plus 5 squared. And this is plus 42 minus 50, right? So that's going to be a minus 8. right? Because this right here is -8. Okay, so if I did x plus 5 times x plus 5, that's x squared plus 5x plus 5x plus 25, right? So that gives me x squared plus 10x plus 25. But remember, we have this 2 times out here, right? So that's 2x squared plus 20x plus 50. But let's not forget, we have this -8 here as well, right? So it's 2 times all of that minus that 8. So we're minusing 8 off of here. So when we simplify that, we get 2x squared plus 20x plus 42. And you see that is exactly where we started. It's just in a different form. So we've checked the work. This is how we check the work. And it is correct. Okay. So now this right here is our formula in vertex form. So now I could say, well, my vertex then is h, which that is a -5, and my k, which is -8. So my vertex is -5, -8. Because remember, this right here is 2 times x minus -5 squared minus 8. So h equals -5, k equals -8. Okay, question.
I have a question.
Sure, go ahead.
How did you get to x plus 5 squared?
The x plus 5 squared.
Yeah, like how did you go from x squared plus 10x plus 25? How did you go from there
So
to...
this tells us what the number that goes right here is. And so that is our b divided by 2. B is 10. So 10 divided by 2 is 5. Right? 5. And then 5 squared tells us the number that we plug up here. And we're going to do more examples. And maybe it'll help be a little clearer when you see it happen multiple times. Does that make sense?
Okay, thank you.
Uh-huh. All right. Let me just make sure that I didn't have another one there. Yep. Okay. All right. So for this next problem, we want to write it in vertex form, and then identify the vertex, the x and y intercepts, and the axis of symmetry. Okay. So let's just we have that our function f of x equals, we're going to factor out this -1 here. And that's going to leave me with x squared plus 2x. Let's leave some space, but we'll leave the 3 out. Okay. So again, if I factor all of that with the -1, I get back to my original. Okay. Now, what is my b? My b is the value that's on the x term. So in this case, my b is 2. But remember, I'll write that here again. I won't write it every time, but remember, we're doing b divided by 2 squared. B divided by 2, that's 2 over 2 squared equals 1 squared, right? So now I know that 1, I'm going to have x plus 1 here squared. Plus I have that -1 out here, but we need to figure out what we put here and here, okay? So I'm not going to skip to that just yet. So the next thing that we have, because this is 1 squared is equal to 1, equals 1. So I'm adding 1 here and minusing 1, but remember, we're going to pull that part out, right? And take that multiple and pull it outside. So that is minus 1 times negative 1. We're going to pull that on the outside. Okay. So that gives me my new equation of negative 1 x plus 1 squared equals 3. Negative 1 times negative 1 is positive 1. So that's going to be 3 plus 1. And that's not an equals, it's just a plus. So plus 4. Okay. So when I completed the square here, I end up with negative x plus 1 squared plus 4. Okay. And that is also could be written as negative 1. I mean, you wouldn't want to write it, but to help visualize the x, the h, and the k, it would be x minus negative 1 squared plus 4. So that shows that my h is negative 1 and my k is equal to 4. So therefore, this problem asked us for the vertex. My vertex is going to be negative 1, 4. We're graphing that, negative 1, 4. We do know that this is a negative, therefore we know that our graph is going to open downwards, right? And then let's see what else. So the vertex, and then it wants us to have the x and y intercepts. So x-intercept is going to be, we do that in just the regular form that we always do. So off of our, excuse me, original equation, we can say where is our x equal to 0? I mean, where does our equation equal to 0? So we could go back to the original if we want. And say negative x squared minus, well, actually, let's just go from the one that's already factored, negative 1 x plus 1 squared plus 4. Set that equal to 0. We'll minus 4 from both sides. And we get negative 1 x plus 1 squared equals negative 4. Can multiply everything by negative 1 to give us, that makes that a positive 1. So that would give us x plus 1 squared. Negative 1 times negative 4 is positive 4. Now we could take the square root of both sides and we get that x plus 1 equals positive or negative 2. Last step for that would be minusing 1 from both sides. So we get x equals, so we'll have a positive 2 minus 1, and we'll have a negative 2 minus 1. So our x can be positive 1 and negative 3, right? So our x-intercept would be when x is 1 and y is 0, and when x is negative 3 and y is 0. That is where we will have our x-intercepts. Okay. For the y-intercept, remember we're just setting our x's equal to 0. Okay. And so that is going to be, come back up here, And so that is -1 times 0 plus 1 squared plus 4. So this is -1 times 1 squared plus 4. So that is a -1 plus 4. So that is a 3. So our y-intercept occurs when x is 0 and y is 3. And then again, axis of symmetry. That is again where x equals h, and our h in this case is -1. So axis of symmetry, everything to the left mirrors everything to the right. Oops. Sorry. So for this one, what we have, let's just plot our intercepts. So we have, why does it keep doing that? We have 0, 3. We have 0, 1, 2, 3. That's our y-intercept. Our x-intercepts are at 1, 0. Here's 1, 0. And -3, 0. -1, 2, 3, 0. That's actually -4. So -1, 2, -3. Okay. You'll see that we're 2 units off the line for each of those. Okay. Here we're 1 unit off the line. So that means with symmetry, we have to have a point here also 1 unit off of the line. Okay. And so this graph would look something like this. Okay. Question. All right. So did that help clear up the question that you had about completing the square and how we get to the value inside of here?
Yes.
Anybody? Okay, perfect. And it does get a lot easier the more you practice it, right? And so hopefully once you have the opportunity to do some of that in the homework, it'll get a lot easier. Okay. All right. So the next thing that we're going to look at here is if we want to determine if our quadratic function has one x-intercept, 2 x-intercepts, or none, right? And so if we can take the b squared, so if you think about in our quadratic formula, if you use like just a regular quadratic formula, everything that's under that radicand, the b squared minus 4ac, if that is equal to 0, you're going to have exactly 1 intercept. If it's greater than 0, you're going to have 2 x-intercepts. And then if it is less than, you're going to have none, right? Because if it's less than, that means you're looking at like the square root of -1, and that doesn't exist, right? And not in real numbers, it's imaginary. So, so keep that in mind. And then we have here, we have, if we're looking at creating our, or coming up with what is our vertex, and I'm in the quadratic form, right? I can actually figure out the x portion of that like figuring out the x coordinate of my vertex, which is the h, right? By just doing -b divided by 2a. Once I have that, plug whatever that solution is back into my whole formula, and that will give me my vertex. Okay. And so that's really what this is here in the short. Okay. And we'll look at it in practice to kind of help us understand it a little bit. Okay. So here we're given this negative 3x squared plus 48x minus 165. And we're asked to determine the vertex by using the vertex formula and by writing the vertex form. Okay. So to write the vertex form, that means we're going to need to do completing the square. So we're going to get a little more practice with that. But to determine the vertex before we do the formula or the completing the square, we're going to use the formula that we were given on the previous slide to determine what our vertex is. Because on the exam, you'll see one of these kind of questions that says use the vertex formula, right? And you'll have to do that. If you don't show the work like that, the formula, then you won't get credit, right? So it'll be testing that you understand that concept. Okay. So by formula, okay, we have x equals negative b divided by 2a. Okay. From our formula here, we have that a equals negative 3, b equals 48, and c equals negative 165. Okay. So in this case, then my x is equal to negative 48 divided by 2 times negative 3. Okay. So that's going to give me a positive 8. So my x value is positive 8. Now I plug that back up into my formula here, right? So I want to evaluate my function at 8. So that's negative 3 times 8 squared plus 48 times 8 minus 165. When I simplify that, I get 27. Therefore, my vertex is 8, 27. Okay. And we'll now, on the other side, let's complete the square. Okay. So we're going to complete the square to determine what is our h and k, so that we can see if that is the same as this solution. And they should be. If not, we maybe made a mistake somewhere. Okay, so this is complete the square. We're going to do that. That is vertex form. Okay, based on vertex form, we have our function f of x. Remember, the first thing we want to do is let's factor that negative 3 out. Okay, so factoring the negative 3, that's going to leave me with x squared. 48 divided by negative 3 is negative 16. Skip some space, and we're going to leave this negative 165 out. Okay, so we're going to take b. Remember, it's b divided by 2 squared. So my b in this case is negative 16 divided by 2 squared. Negative 16 divided by 2 is negative 8, but that's still squared, parentheses around the negative. Okay, so that tells me that when I come down here, I'm going to have x minus 8 because that's a negative 8. Okay, and that's going to be in the squared. And then we have the negative 3 out here. And so really what we need to determine is the remainder of that. So negative 8 times negative 8 equals 64. So I'm going to add 64 and minus 64. But remember, we want the minus 1 to be on the outside. Not wrong color. So we actually want that to be negative 3 times 64 out there. Okay. All right. So, what else? Actually, yeah.
Is that the negative 64?
Yes. Yes, the negative 64. Sorry. Let me shrink this a little bit. I'm going to rewrite that. So we ran out of paper space over there. This is minus 165. And this one is minus 3 times negative 64. Okay. Thank you. So, actually, this one. All right. So the last thing we have to do is negative 165 minus negative 3 times negative 64. That becomes positive right there, right? And so this is going to leave me with a positive 27, right? So this gives me here that my H equals 8, my K equals 27. Therefore, my vertex is 827. And you can see by either method, I get the same solution. So on the exam, you'll have a problem that says use the formula. You must do this, okay, for that problem. On the exam, you'll also have a problem that says do it in vertex form, and it requires this method, okay? If on the formula one you do the vertex method, then you get no credit, and vice versa, okay? So, and I'll reiterate that when we are doing our exam review next week, but I just want you guys, as you're doing homework, to get in the practice of when the homeworks are saying to use the formula, use the formula. When the homework says do vertex form, do vertex form, so that you get that practice both methods. Okay? Question. All right. So what I have here, it's just it's always good to do a little bit of application kind of problems because it helps kind of think through some of the terms and things that we're doing, but in real world application. And so at the end of his career, Sherlock Holmes retired to a small farm in the country and took up a hobby in beekeeping. Being of an analytic mind, he could not just watch the bee fly from flower to flower. He formulated a mathematic model for the path that the bee went from flower A to flower B. And that's given here with this negative 0.03x squared plus 1.8x minus 24. Okay. So we want to know what is the maximum height that the bee reaches as it flies from A to B, right? So that maximum point is what? That's really just your vertex. So we could do that, right? We have the ability to do so. So we could do that simply by using the formula. So we could say x equals negative b divided by 2a. So my b is 1.8. So negative 1.8 divided by 2 times negative 0.03. And that's going to give me simplified down 30. So I plug that into my formula. So my function evaluated at 30 is 0.0, it's negative 0.03 times 30 squared plus 1.8 times 30 minus 24. And that's going to equal 3. So that is about 3 inches high, is the height is the height of the maximum height that the bee reaches as it flies from flower A to flower B. Inches, feet, whatever it might be. This didn't actually give us units. So we could say 3 inches. You could say it was 3 feet because the problem itself didn't define. Okay. Question. Part B says, how far away from Sherlock Holmes are flowers A and B? Okay. And so flowers are at the x-intercepts. Okay. And so you can see that where the flowers are, so the x-intercepts. So we have the negative 0.03 x squared plus 1.8 x minus 24 is equal to 0. I don't like dealing with all the little numbers, so I'm going to, or the decimals, so I'm just going to multiply everything by 100 so that we end up with 100 times this negative 0.03 is going to give me a negative 3x squared plus 180x minus 2400 equals 0. Okay. Now, if I divide everything by 3, if I divide all of this by 3, I can simplify my equation a little more, and I get x squared minus 60x plus 800 equals 0. And then we can just simply factor this as x minus 20, x plus 20, minus 40 equals 0. So x is at 20 and 40, right? So if we're looking at that, this is x equal 20, this is x equal to 40. So what that's saying is the distance from Sherlock to flower A is 20 units, and the distance from Sherlock to flower B is 40 units. Okay, question. All right, so the last thing from this section is being able to do this in your calculator. Obviously, you will not have a question that requires you to do this on the exam, but you will need to be able to do it for some of the homework. So this really just, it's in your textbook, but this is, everybody has a different calculator, right? So I can't give you an example of how to do everything in each individual calculators. But this is a way, and it can give you some hints how to help you figure out yours. You can always reference your specific calculator's user manual. But in this case, if I wanted to do a quadratic regression, I would use the stat button on my calculator, hit edit, and enter values for x and y. So remember, f of x really is the same thing as y. Okay, so to enter 8, 10, 12, 18, etc. for my x. For y, I would enter 5, 10, 13, 23, etc. Once I've entered those 2 into my list of data, then I can go to the stat button, hit calc, and choose number 5. I want to do a quadratic regression and enter this formula here. Okay, so here's the picture. I go to my calculator, my calc button, and choose option number 5. When I plug in, when I go to my quadratic regression, I can enter over here. You could see it gives me my y, but then I can enter A, B, and C. over here into this. And then we're able to graph it. We can change the color of the graph, and this would all just show you some of the niceties that you can do with that there. When it's all said and done, you plot this data here, but when you add that regression, notice that it puts that line in there, the parabola in the graph for you. Okay? Question. All right. So since we have 3 sections tonight, I'm going to go ahead and move on and talk a little bit into section 2. We'll go to about 8 o'clock, take a break, and then finish out probably the other half of this section, if we don't get through it all, and go into the 3rd section. Okay? Any questions before we start talking about polynomial functions? All right. So this here, what you're seeing is, I want to give it to you guys. I want to make it as easy as possible for you, so you don't have to go digging in the textbook for these sort of things. So remember, all of this will be posted in our classroom shortly after the conclusion of our class this evening. So what we have here is, when you see this X and then an arrow to something, that is just saying X approaches infinity. So you could think of that arrow, instead of saying X arrow infinity, just think of arrow can be replaced with the word approaches. Okay, so X approaches infinity, or X approaches negative infinity, or we have f of X approaches negative infinity or whatever, right? And so really, what does that mean? Well, as X approaches infinity, if you think about it, if I have a graph here, and here's X equals 100, here X equals 1,000, 1,000,000, right? We have all these things. So as X goes in this direction and increases extremely large to an infinite number in size, right? So X becomes infinitely large in that positive direction. The opposite would be true if X approaches negative infinity. It would become infinitely large in the negative direction. Okay? Similarly, f of X approaches infinity in the positive direction, or upwards. It means that the Y value is becoming infinitely larger in the positive direction. And if you have, as f of X approaches negative infinity, that means it's going to approach negative infinity, Y is going to become infinitely large in the negative direction. Okay? So our standard polynomial is given by this formula here in the middle of the page, where we have a sub n times x to the n plus a sub n minus 1 times x to the n minus 1. So let's just say that we had n equals 3. So essentially, that's just saying A3 equals X3. So that's saying my A3 is just the A value, or that constant number in front of the X cube. Okay? Plus, then we would have AN minus 1, X minus 1. X3 minus 1. Plus, and then we would keep going until we got A0, right? Well, I'll show you in this. So that would be A3 minus 2, K3 minus 2, plus A0, 3 minus 3, k, 3 minus 3. So that all simplifies to a3, k3 plus a2, k2, x2. I don't know why I said k. Sorry. Plus a1, x to the 1 plus a0, x to the 0. Okay. And x to the 0, anything to the 0 power is 1. So that's how that comes about. So how does this translate? So this is going to help us when it comes to graphs, because if our leading term, right? So this right here is considered our leading term. Okay. So if our leading term has an even exponent, how does our graph behave? And this can be either positive or negative on our constant, right? So if our constant is positive and it's even, our graph is going to be up in both directions. So that would look something, it could look like this, right? A standard parabola. It could be something like this. It could be whatever it may be, right? But the end behavior is what we're getting from it. Okay. Similarly, if our AN is negative, right? So let's say that had been negative 2 x cubed or x squared or whatever, right? That means that we're going to be, both of our value arrows are going to be down. And again, just like the previous example, it could be any sort of number of hump changes, etc. But that at the end of the day, this end and this end both must be in the downward direction. Okay. If we're looking at odd now, if that exponent is odd, so maybe it's just 3x, or maybe it's 3x to the 3, or whatever it may be, then we're going to be dropping to the left and rising to the right. Okay, so it could be something like that as well, but to the left we're dropping, to the right we're rising. Okay. And then the last one is if a to the n is negative and x is odd, or the exponent on x is odd, then it's going to be the opposite. So we'll be increasing to the left, decreasing to the right. And it could be anything like that. Okay. And I'm not sure, sometimes when I post these, so this was a F, this should have been an F. Sometimes when I copy and paste these little pictures, they don't necessarily always come through just perfect. Let me erase those out of there so there's no confusion. Okay. So what that's telling you, as x goes to negative infinity, right? This direction, then my function goes up here, my y goes to positive. So as x is negative infinity, y is positive infinity. That tells us that if we were in a graph, we have negative infinity for x, positive infinity for y. So we're somewhere up here, the rest of the graph is here. So that's why we know that that is up there in the positive direction on that arrow. Okay, question. So let's look at it in an example form. Okay, so it only is dependent on the leading coefficient, so we can single that out. So our leading coefficient here, we can see that this is positive, right? And we can see that this is odd, okay? So positive and odd tell me that I'm down here, up here. So I would be down to the left, up to the right. Okay, question. Okay. So for this one, we can't just do this, right? Because we'd have to do all this out. But I will let you in on this. Here, the biggest thing here is going to be x cubed. This is going to be an x and a 2. So when we multiply all of those first term things, we end up with a, actually it's a -2. We end up with -2x to the 4th power. Okay. So that tells me here that I am negative and even. Okay. So when I'm negative and even, then I'm down to the left and I'm down to the right. That's all this is telling us, is that we don't know what this in between is. We don't know what's in between yet. We're going to get some more tools as the night progresses to be able to fill in the middle of those arrows. Okay. But the end behavior is a good indicator as to how we can come up with some of what the graph should look like. Yes, go ahead, question.
Professor, how did you get the x3?
x3?
Mm-hmm.
Yep. So if I had x plus 1 times x plus 1, right? Times x plus 1, because that is a cube. So when I do this, I end up with x squared plus all this other stuff times the x plus 1, right? So if I just did this one first, and then when I do this outer pieces here, I end up with x cubed plus all the other things. But because we only care about the leading coefficient, all that other stuff doesn't matter.
Got it. Thank you.
Uh-huh. All right. So now let's look at some other things that can help us quickly identify these graphs. Really, all of this is going to help us be able to graph these things much quicker than plotting 20 points or whatever to get a good picture. Okay, so the values of x when we have f of x equal to 0, that's called zeros of the function, right? So it's a 0 of the function because essentially, right, this is y equals 0. Well, if I'm looking at a graph here and y equals 0, that is where my graph crosses my x-axis, and it is a 0 of the function. So these are real solutions or roots to that equation, and it corresponds with the x-intercept that we've learned how to do since week 1. Okay. So we want to determine the zeros of this function, x cubed minus 5x squared minus 16x plus 80. We're going to do what is called factoring by grouping. Okay, so we're going to factor by grouping. So that is a term that if you aren't super familiar with it, we're going to go through. I'm going to teach you how to do it, But if you want extra guidance on that, you can always go to Khan Academy and get some extra videos on that as well. Okay. So factor by grouping. Let's just get two colors. I'm going to factor the first two things together, and then let's factor the second two things together. Okay. So first, if I look at just the blue box, what can I factor out of both terms? You can notice that both terms have an x squared in it, right? If I take an x squared out of x cubed, it leaves me with x. If I take an x squared out of 5x squared, it leaves me with the 5. So if I distribute this, I get right back to that original equation, or the portion of it that's in the box. Okay? So now let's do the same for negative 16x plus 80. Let's factor a negative 16 out of that. If I take negative 16 out of negative 16x, I'm left with just an x. If I factor a negative 16 out of 80, I'm left with negative 5. Okay. Now I want to factor by grouping again. So I look at this term and this term, and I say, what do they have in common? What can I factor out? And you'll see that both of them have this x minus 5. So let's factor an x minus 5 out of each term. If I factor an x minus 5 out of the blue, I'm left with x squared. If I factor an x minus 5 out of the green, I'm left with the negative 16. Okay. So my zeros then, if I'm saying if this whole thing is equal to 0, right? Because that's what we're asked to determine the zeros. So either x minus 5 equals 0, or x squared minus 16 equals 0, because there's no other way that this formula could equal 0 unless one of these two conditions is true. So we can add 5 to both sides, and I get x equals 5. So if x equals 5, I plug 5 into that equation, and I will end up with 0. Okay? Or I can add 16 to both sides for this one, and I get x squared equals 16. We have to divide both sides by this, or take the square root of both sides, and I get x is equal to plus or minus 4. So I can say that if x equals 5, my formula is 0. If x equals positive 4, my formula is 0. If x equals negative 4, my formula equals 0. Okay? So that's what it means when we're asked about the zeros. Okay? Question. Nicole, I am just seeing the negative 5. Were you asked why negative 5? Were you saying here why negative 5 in this one, or on a previous problem?
On this one, so when you like negative 16, if you take from the negative 16x,
Uh-huh.
but when you take negative 16 from 80, is it 5?
Negative 5, right? Because negative 16 times negative 5 gives me that positive 80.
Oh, okay. Thank you.
Uh-huh. Any other questions? And also, if I ever, because I'm like, I have like the questions pop up on my laptop, but I'm writing on my tablet on a different part of the desk. So if I ever miss a question and we move on and I did not answer a question, please, everybody, feel free to just unmute your microphone and be like, hey, quick question, okay? Because I don't want to move on if you're not understanding, okay? It looks like some of the parentheses didn't come with that. So, okay. Now if we want to determine the zeros and their multiplicity, so basically, if you look up in the if a polynomial function has a factor of x minus c that appears exactly k times, then c is a multiple of is a zero with multiplicity of k. What does that mean, right? So long story short, this here is x minus c, where c equals 1, okay? So this is x minus c, so c in this case equals 1, okay? This one is x minus c, where c equals -3, okay? And so what that is saying is, so when I have this x minus c, and we have some k up here, this is k, then that tells me it's my multiplicity. So in the first term, we have 8x equals 0. So x equals 0. This happens only one time because there's no exponent here. It's a 1 with multiplicity equal to 1. Okay. For the next one, we have x minus 1. When that is 0, we add 1 to both sides, and we get x equals +1. But this has an exponent with 2, so that's with multiplicity equal to 2. And I'm going to change the color here. Green. So if there's not an exponent, it's implied it's a 1, right? And then finally, for this last one, we have x plus 3 equal to 0. So we minus 3 from both sides, and we get x equal -3. And that's going to have multiplicity of 3 because of the exponent. Okay? So the zeros would occur at x equals 0, x equal 1, and x equal -3. But it really, with this multiplicity, is giving us more information, because essentially the graph would, it'll lead us into this next section. Does it touch the graph? Does it touch the x-axis? Does it cross the x-axis? And how we can determine. Okay. Question. All right. So I mentioned, does it touch the graph, cross the graph, etc. So on this problem, this first one here, notice it's the same thing. X times x minus 1 times x plus 3. The only thing that changes is the multiplicity. And that is so that you could see the effects of it in each of the following graphs. Okay. So in this case, we have x cubed, right? So if we did x, that's going to eventually give me x cubed as my leading coefficient, and they're all 1s. So this is odd and positive, right? So we're odd and positive. So we'll be dropping to the left, rising to the right. You could see we're dropping to the left, rising to the right. We also should have 3 zeros. We have 1, 2, 3, because we have exponent 1, exponent 1, exponent 1. So we should have 3 crossings of the x-axis, and we do see that. We see that they all cross here. Okay? Question. Okay, for the next one, we have exponent 1, exponent 2, exponent 1. Okay, so we have 1, 2, 3, 4 x's, right? Because this is x squared. So we would have x squared times x. That gives me x to the 4th. Everything is positive here. So we have positive and even. Let me put it in the same order, even and positive. That means we're increasing to the left and we're increasing to the right. And you can see that on both of those ends. Now, I am going to have an intercept at x equal to 0. I have an intercept at x equal to -3 based on this. But you see this right here is at +1. And notice, because that is an even exponent squared, I didn't actually cross the axis. I actually just touch it, turn around, and go back up. Okay? So in this case, I'm going to touch at x equals 1 and go back to change my direction. For the last one here, we have x to the 1, x to the 1, and we have the 2 out here. So in this case, we still have x to the 4. We're still even and we're still positive. So we're going to be rising to the left, rising to the right, which we see here on this graph. But now at x equal to 0, we have that 0. This, if x is +1, that equals 0. And if x is -3, it equals 0. But x equal to 3 is the one that has the even exponent. So you'll see that it comes in and it touches and it goes back. It doesn't actually cross the x-axis there. Okay, and so that's really what this here is getting to. If C is a 0 of odd multiplicity, then it's going to cross the graph. Okay, 1 is odd, so it crosses the graph. If C is a 0 of even multiplicity, so those two 2's, then it just touches and goes back in the other direction. Okay, question. So we have the opportunity to do one example here. So the first one we have here is -3x squared. So this would be x equal to 0 with a multiplicity of 2, right? Because of that 2 exponent. Because that exponent is even, we're going to touch the graph at 0 and go back in the same direction, like change directions. Okay. For the next term, we have x plus 4 equal to 0. So x equals -4 if we minus 4 from both sides. We have our exponent here is odd. That one was even. So our exponent here is odd. So that means we're going to cross the axis. Okay, and for our x minus 7, add 7 to both sides, I get x equal to 7. And let me scooch this over a minute. This is going to be multiplicity of 3. That is an odd number. Since it's an odd number, it crosses the axis. This one was multiplicity of 1. Okay? Question.
I have a question.
Sure.
So let's say a question asks you how many zeros are there, and there's, let's say, 2 that crosses and 1 that touches. Would you say there's 3 zeros or only 2 because only 2 cross?
Your zeros are going to equal however, So like this one has to have 4 zeros. This one would have 4 zeros. This one would have 3 zeros, right? The problem is, and we'll get into this as the course progresses, some of them are real and some of them are imaginary.
Okay, so the zeros like only depend on the exponent of the leading term, or no, not the leading term of all of the terms, right?
All the terms, yeah.
Okay.
And when I say imaginary, if you remember back to probably like high school algebra days, when you deal with imaginary, well, you could call them imaginary or complex numbers. Remember, they have to come in pairs, right? So if I have an I have to have the plus I and the negative I, right? And so those come in what's called conjugate pairs, and we will get to that in this course. Just I don't think we're going to see that in tonight's lesson. Okay. Good question, though. One more term. We're going to do this and then we'll take a break. It'll be good because then we're going to get into how to graph all of this. So it'll be a good point to take a break. This term here really is how many turning points does our graph have? And essentially, the degree of your polynomial. So if we look over here at this is the degree, right? It's a 4th degree polynomial, meaning that the largest that we have up to the leading term at most has 4 in the exponent. So when we're talking about turning points, our turning points are really just n minus 1. Well, this is the number, my exponent, right? So in this problem, it would be 4 minus 1. So how many turning points do I have? So I have, well, let me get a different color. I'm coming here, I have 1 turn, 2 turns, 3 turns. 4 minus 1 was 3, right? Okay. What about over here? 4. So I'm coming, there's 1 turn, 2 turns, 3 turns. I have at most 4. It doesn't tell me that I have exactly 4. It just tells me the most turns I can have. This one, exponent of 3. So 3 minus 1, the most turns I can have is 2. There's 2. You can see I didn't have any more than 2. All right. So at most, it doesn't tell you exact equals. That's the key word right there, is at most. Okay. So give the maximum number of turns here. You really just look at this leading coefficient. So in this case, n equals 3. So 3 minus 1 equals 2. There are at most 2 turns. So if we're going through here, there's 1 turn, 2 turns. You could see we had a turn here and a turn here in our graph. At most 2 turns. Okay? Question. All right. Let's go ahead and take a 10-minute break, and we'll come back at 8:10. Let's come back at 8:10, and we'll finish out this section and do one more. Okay?
Professor?
All right, so now it is 8:10, so let's go ahead and keep moving forward with the lesson. So now we have a little bit more information, and we can use that to help us graph these polynomials a little easier without having to plot a bunch of different points. So we can use our leading term to help us determine end behavior. We can calculate our y-intercept. We can do our real zeros, right? I mentioned real and imaginary, and their multiplicities. This is going to give us where our x-intercepts are. We can plot those x and y-intercepts on a graph and sketch in that end behavior. And then we can kind of sketch that, knowing what we know with the multiplicities. Are we going to cross the x-axis? Are we going to just touch it? And then we can use our symmetry as well to help us fill in any of the details. Okay, so I put this here for you so that you can use it to help you use it as a guide, right? Again, you know, when it comes to the exam, though, you'll need to have this information memorized, because you don't get to have any extra aids on the exam itself. All right, so how are we going to graph this? So the first thing, this here, that means we're going to have an x squared, right? And we're going to have an x as our leading term here and an x here. So x squared times x, that's going to give me an x to the 4th power, right? So I'm even and I'm positive. So my general shape is my end behavior is going to be up in both directions. Okay. And so then when it comes to the turns, right, that's n minus 1. So 4 minus 1 is 3. So we're going to have at most 3 turns. Okay. For our intercepts, we're going to have f of 0 equals -1, because this is just going to, we're just plugging in 0 minus 1 squared, 0 plus 3, 0 minus 4. So when we do all of that, that simplifies to -12. So our y-intercept is going to occur at 0, -12. Okay. When we look at the touches, this is, we have the x minus 1 squared, x plus 3 to the 1st power, and x minus 4 to the 1st power, right? So this tells me that my zeros, right, if we were to determine what the zeros are, x equal to 1 is going to make that 0. X equal to -3 makes that a 0, and x equal +4 will make that a 0. Now I look at my multiplicity or my exponents there. It's even, so here we're going to just touch. This one, we have the 1 exponent, so the exponent is 1, so that's odd. So we're going to cross. And here we're a 1 as well, and so we're going to cross. Okay. So in this point, we can also use, remember, we can use symmetry. So this is from last chapter. So if I plug in -x, that's going to give me -x minus 1 squared times -x plus 3 times -x minus 4. That is not equal to my original function, and it is not equal to the negative of my entire function. So I'm neither odd nor even, so that's not going to help me define the shape with symmetry. Okay, So now let's just plug in some of the data points that we do know. We know that our y-intercept is at 0, 12. Notice that this goes to negative 70. So this is 10, 20. So negative 12 is probably about right here. We can also plug in our zeros. We have a 0 at x equal to 1. We have a 0 at x equal to negative 3. And we have a 0 at x equal to 4. Okay. We also know that at x equal to 1, that we're just going to touch and not cross the axis. Okay. We also know our end behavior tells us that this last point is going to be up and this last point is going to be up. Right? So really what we know now is that there's something in here like this, right? Because that one just touches. But let's pick one point in this space and a point in this space to kind of give us a little more definition to our graph. So if we pick a point that's between, let's say, negative 3 and 1, right? We could pick, let's pick negative 2. Okay, so we plug that in and we get negative 2 minus 1 is negative 3 squared, not plus, times. Negative 2 plus 3 is 1, so that's 1 to the 1, times negative 2 minus 4 is going to give us negative 6. Okay. And so that's going to give me 9 times 1 times 6. And so that's going to give me a negative 54. Okay. Actually, this is negative 7, sorry. Because we're doing negative 3. I don't know why I put a negative 2 there. Negative 3 squared. So that would, this one would be, let me just write them out. Sorry. So this is, if I choose x equal to negative 3, that's negative 3 minus 1 squared, negative 3 plus, oh, we don't want to do, we want to do it between, we do, sorry. If we pick negative 3, then that becomes a 0 and the whole thing is 0. So we want it to be negative 2. So negative 2 minus 1 squared, negative 2 plus 3 to the 1, and negative 2 minus 4. Okay. So that is negative 3 squared times 1 times negative 6. So I was correct, sorry. So 9 times 1 times negative 6 is a negative 54. Okay. So negative 54, so negative 1, negative 2, here's 10, negative 20, 30, 40, 50. About right here is where that point would be. And then let's pick a point between these 2 points. So we could pick either one between 1 and 4. So let's just pick 3. Okay, so we'll pick between 1 and 4. So we're going to pick positive 3. That is going to give me 3 minus 1 squared times 3 plus 3 times 3 minus 4. Okay, so this gives me 2 squared plus not plus, times 6 times -1. And so that's going to be 4 times 6 times -1. That's -24. And so we chose x equal to 3. So there's 1, 2, 3. And we're -24. Here's -10. Here's -20. About halfway there is this piece. So when I look at this graph, I know that I'm coming from this direction and I drop down here and I come up here. I'm going to touch the graph, not cross it, come back, grab this point, and come up. And so that is the rough shape of that graph, strictly by doing all of these things that we've learned the techniques for, rather than plotting every number from -5x to +5x to get that value. Okay? Question. Okay. All right. So let's look at another example. Okay. So we want to sketch negative x plus 1 times x minus 3 squared. Okay. So here our shape is, this is going to be our leading is negative x. This would be an x squared. So when we multiply those together, that becomes negative x cubed. Okay. So our shape is based off of negative x cubed. So that means I'm going to be rising to the left and dropping to the right. I will also know that I have at most 2 terms, right? Because n minus 1 equals 3 minus 1 equals 2. Okay. My intercepts, I have f of 0 is equal to -1 times -3 squared, because all I'm doing is plugging in 0 for my x's. This is going to give me -1 times 9 is a -9. So I have a y-intercept at 0, -9. So we can come in here, 0, here's 5, 10. So -9 is about right here. And now let's calculate our x-intercepts. So I have negative x plus 1, x minus 3 squared equal to 0. Therefore, x plus 1 equals 0, or x minus 3 squared is equal to 0. If it's this one, we're minusing 1 from both sides. We get x equal to -1. Or if I take the square root of both sides, I get x minus 3 is equal to 0. Add 3 to both sides, I get x equals to 3. Okay. So I have y-intercepts that cross at -1, 0 and 3, 0. Okay. I have a multiplicity of 1, right? Multiplicity of 1. So this tells me I cross the axis. This one, I have multiplicity of 2. So this one tells me that I just touch, because it's even multiplicity. Okay. So from all of that, we can come in here, -1, 0, that's an x, and 3, 0 is an x. I do know that my end behavior, remember I'm up in this direction and down in this direction. So, and we're just touching at this one. So let's make that we're just touching. So let's just go from left to right. So we know that our graph is going up here. So it comes down here. We're going to come here, touch, and come back down. And so that is a general estimation of what that graph would look like. Okay, question. All right, so this is the last idea for this section, and it is the intermediate value theorem. And so what this is really helps us with is to tell us if there's a zero between some specific interval, right? So if I have a polynomial, and I want to look at two x values on an interval, say from A to B, and I evaluate those at y, and if they have opposite signs, then that means that it has at least 1 0 on that interval. Okay, so let's look at this. This is our interval is -1 to 0. Okay, and so let's evaluate at that f of -1. So when I plug that in, I get -1 cubed minus 13 times -1 squared plus 33 times -1 plus 33. When I simplify that, not 33, 35. When I simplify that, I get that equals -12. This here is a negative value, right? So now let's evaluate on the other end of our interval. And so we have 0 cubed minus 13 times 0 squared plus 33 times 0 plus 35. When I simplify this, I get 35, which is positive, right? So what our theorem here tells me is if I do this on the interval and I get opposite signs, then that means I have at least 1 0 on that interval. Okay, so there is at least 1 0 on the interval -1 0. Okay, so where is -1? Here's -1, here's 0. And so on this interval, they're saying there's at least 1 0, and we actually can see that here on that graph, right? Okay, question. All right, let's look at the last section then. Our last section is, I think that this is some fun stuff. It's division. So we're going to look at division of polynomials. So we're going to learn two techniques. We're going to learn how to do long division, and we're going to learn how to do synthetic division. Okay. Think of long division in the terms of think back to like 3rd, 4th grade when you had to say, I want to do, 125 divided by 25 or whatever, right? And it was numbers that we didn't really know at that time how to just do real quickly in our heads. So we had to do what we would call long division, right? Like even if I had, say, 125 divided by 5, right? That would be 5 divided by 125. We would say 5 goes into 1, none. 5 goes into 12 2 times. 2 times 5 is 10. And then we subtract it from there, right? And that leaves me with 2. And then we would bring down this 5. And 5 goes into 5 goes into 25 5 times with the 25. We subtract those, and we have a remainder of 0, right? Does everybody remember doing long division? Now, we're going to do long division, but we have polynomials. So as long as my divisor is not equal to 0, we can do that, right? My denominator cannot be equal to 0, otherwise it's undefined. All right, so how do we do this? So we just do it the same. So we have 2x minus 5 divided by, these values have to be in descending order. So right now we have x cubed, x squared, x to the 1, x to the 0, or there's no x there, right? So we're okay. We don't have to do any rearranging. So we just write 2x cubed minus 11x squared plus 13x plus 15. If I had any missing, I would need to fill those in as well with the 0. Like if I didn't have any x squareds, I would have needed to put minus or plus 0x squared in there, okay? Now, ultimately, I need to have a value here that is 2x cubed so that when I subtract them, that goes away, okay? So what do I need to multiply this problem here, this to give me 2x cubed, okay? If I multiplied that by x squared, I get 2 times 2x gives me 2x cubed. 2x squared times, sorry, x squared times 2x gives me 2x cubed. But I have to do it to this term and I have to do it to this one. So that is minus 5x, okay? Now, I'm gonna just make that the red, okay? Oops. Sorry. But what we do want to do is essentially we're subtracting that from it, right? I don't like the parentheses around it. So I always just change all the signs in everything. If you change, because that's the same as putting a negative and parentheses. So I just change all the signs. And these will go away, right? And I have negative 11 plus 5 gives me a negative 6. And that's an x squared because you have x squared times 5 is 5x squared. Okay, and so that gives me an x squared. Now I need to just bring the next number down, which is 13x. So just as I did before, what do I need to multiply here to give me negative 6x squared? And that's going to be 3x, right? So let's do, this is going to give me negative 3x. So negative 3x times 2x is going to give me negative 6x squared. Negative 3x times negative 5 gives me positive 15x. And I need to change the signs of each of the terms. And that makes the first term here go away just as we need it to. And we have 13 minus 15 is a negative 2x. And we'll bring down our last term out here, plus 15. And so I have negative 2. I need to, what do I multiply it by to give me negative 2x? And that is going to be, I need to multiply this here then by a negative 1. Negative 1 times 2x gives me negative 2x. Negative 1 times negative 5 gives me a positive 6. I need to see that these terms go away because I'm going to change the sign of each of these. And I have 15 minus 6 gives me a, not 6, this is a 5, sorry. 15 minus 5 gives me a positive 10. And so this here is my remainder. So I would write this as x squared minus 3x minus 1 plus 10 over 2x minus 5. Okay, question. All right, so we have a couple of more here to look at. I won't go as slow through these, but the one thing, so we always should check, we have x to the 5, x to the 4. We're missing the x cubed. Then we're also missing x squared, right? So we want to have 0 of these and 0 of the x squared to add to ours, right? Because remember, we have to have all those placeholders. So this is x minus 3. We have x to the 5 minus 3x to the 4 plus 0x cubed plus 0x squared plus 12x minus 33. Okay. So in doing this, we have, how do I get x to the 5? I'm going to multiply x to the 4. Okay. So if I have x to the 4, I can say 4 times x, or x to the 4th times x is x to the 5 minus 3x to the 4. Change the signs. This goes away. This gives me 0 x to the 4. Bring this plus 0 x cubed plus 0 x squared plus 12x. Okay, so now we have something we can do. What do I need to multiply this by? I need to just multiply it by a plus 12. So 12 times x gives me 12x minus 36. Okay. I could have brought this minus 33 down here. And so now I need to change the signs. This goes away. And I am left here with a positive 3. So the solution to this one then, let me shrink this just a little bit to not be in the next problem's way. And so the solution here would be x to the 4 plus 12 plus 3 divided by x minus 3. Okay, question. Okay, so for this last one, we have x squared minus 3x plus 4 divided by, we have a cube squared to the 1 to the 0, so we don't need to add any. We can just put 2x cubed plus 2x squared minus 16x plus 32. Okay, so this is going to be 2x. 2x times x squared gives me 2x cubed. Remember, we have to do it to all the terms. So this is going to be minus 6x squared. And this one would be plus 8x. Okay. Change all of the signs. So we change the signs and add them together. So those are going to cancel with each other. And this gives me 2 plus 6 is 8x squared. And 16x minus 8 is negative 24x. And bring down the 32. Okay. Now we need to multiply this top by 8. So 8 times x gives me 8x squared. 8 times negative 3x gives me negative 24x, and 8 times 32 gives me, 8 times 4 gives me 32. I need to change all of my signs, and this goes away, but actually, so does this. This gives me x to the 0 plus 0, and thus this solution would be 2x plus 8. Okay, questions?
I have a question on the last one, the one that's in red.
Sure.
Where's the last part 3 over x minus 3?
So let's think back. Did I erase this one? Yeah, I erased the division I did over here. So let me do, if I had 5 divided by 122, right? It doesn't go in there perfectly, so it goes in 2, 10, 2, right? We bring down this 2, and it goes 4 times with a remainder of 2. Do you remember that from probably 3rd, 4th grade? So it could be a long time back, right? Because we really don't do division in this long method anymore. But we could have always written that as, oh, that solution is 24 and 2/5, right? So that's the same idea that we're doing here. It's all of this plus my remainder over my divisor here. Because that's what's left is 3.
That makes sense. Thank you.
Yeah. And so instead of 3/5, it's 3 and that x minus 3. Okay. Good question. Does anyone else have any questions? All right. So now let's look at synthetic division. Okay, synthetic division, you're going to end up with the exact same answer that you would get if you use long division. It's just much quicker, but not every problem. You can't use synthetic division on every problem. So let's come back over here. We can use synthetic division on this problem because it is linear. It's just an x. You cannot use synthetic division on this problem because the x is not singular, it's squared or more. Okay. So in this case, we're going to be looking at x minus 8. That's linear. We can, so it's in the form of x minus c, so we can use synthetic division here, okay? So the first thing we want to do is we want to write our value c in a box. So in this case, this is x minus 8, so c equals 8. So we're going to write our c value in this box here. Okay, it's half of a box. All right. Now we want to write the coefficients of the dividend to the right of the box. And we need to make sure that they're in order. So here we have x cubed, x squared, x to the 1, x to the 0. They are in order. So we're not writing the x's, we're only writing the coefficients. So the first one, this is a 1, negative 13, 46, negative 49. Okay. Now we want to skip a line and draw, so we'll, like as if we were going to write something in here, and we're going to draw a horizontal line. Okay. Now we want to bring down our first coefficient right here. Okay. This is what we call the set. Now the rest is we're going to do all this math calculations and the division, and we're going to repeat the process till we get through all the numbers. Okay. So here you can read in the words to the left here, but essentially this is what it is. So I have this set up. right? I'll copy it just so that you guys can see the setup is up there. And this is us working through, okay? So does it do that? I don't know why it's doing that. Okay, so now 8 times 1, right? So you're just think of this right here as times. So 8 times this number goes here, right? So 8 times 1 equals 8, goes there. Now we just add those together. So negative 13 plus 8 is negative 5. Okay? Now, 8 times negative 5 is 40. Negative 40. 46 plus negative 40 is negative 6. 8 times negative 6, actually it's positive 6 because 46 is bigger. 8 times 6 is 48. Negative 49 plus 48 is a negative 1. Okay? So now you could think of this as we started out with an x cubed, so we minus one of those off, right? So if we start with x cubed, then this is x squared, x constant remainder. Okay? So my solution then is x squared, or 1x squared, minus 5x plus 6 minus 1 over x minus 8. See how that was much simpler than what we did on the previous problem, right? And I want to display this to you. Remember, we did this problem right here, this long division, right? I'm going to do it over here using synthetic division to show you exactly how it works no matter which way you do it, right? So here we had, so in this case, my C equals 3. Because what's going to make this 0, right? So x minus 3 equal to 0. So x equals 3. So you could think of it like that too. We're going to put that positive 3 over here. Our coefficients, so here's x to the 5, 4, 3, 2, x to the 1, and our constant. Okay, skip a space. Here's that. Draw this line down. And now we have our setup, right? That's our setup. So now 3 times 1 is 3. Negative 3 plus 3 is 0. 3 times 0 is 0. Adding 0 is 0. So 0 times 3 is 0, plus 0 is 0. 0 times 3 is 0, plus 12 is 12. 12 times 3 is 36. 36 minus the negative 33 is a positive 3. So our coefficient that we started with was x to the 5. So this is x to the 4, x to the 3, x to the 2, x to the 1, x. X to the 1 is that. This is constant and remainder. Okay, so we would write this as x to the 4. We don't need to put plus 0, plus 0, plus 0, but plus 12 plus my remainder, which is 3, divided by x minus 3. So we get x to the 4 plus 12 plus x to the plus 3 divided by x minus 1. When we come back over here, you see that's exactly what that answer was by the long division. So you can see many people prefer synthetic division over long division. On the exam, you will have one that says use long division. You'll have one problem that says use synthetic division. So make sure when you're doing your homeworks, I don't really have a way to check and make sure you did long division, synthetic division on homework. So do it as you choose, but you're doing yourself a disservice if you don't practice both. Okay? Question. All right, let's look at another example of long division. Here, this, remember, our form is x minus c, so this is x minus negative 10. So my c in this case is negative 10. So that is what we're putting in that box, is negative 10. Okay. Notice that these are out of order, right? Because I go x cubed, x to the 1, x squared. So I need to, when I place them on this line, I need to make sure that they're in order. So, and I need to do it in descending order. So my cubed is a 3, my x squared is 25, x is negative 48, and then my constant is 20. Okay. Questions? Let's bring down that first term. So 3 times negative 10 is negative 30, plus 25 is negative 5. Negative 5 times negative 10 is positive 50. Minus 48 is 2. 2 times negative 10 is negative 20, plus 20 is 0. Okay, our highest exponent is x cubed. So this is going to be x squared, x, my constant, and my remainder. So I could write this out as 3x squared minus 5x plus 2 as the solution. Okay, question. Okay, so we have what's called a remainder theorem. And so basically what that's saying is that if we have a polynomial and it's divided by this x minus c, then the remainder is whatever c is evaluated at x, right? So we put in c in and evaluate that. Now, the value of c is the same as the remainder that we'll get by doing this division, okay? So for this first problem, it says, given that we have f of x equals 5x to the 7 minus 3x to the 5 plus 2x squared minus 1, we want to use this remainder theorem to evaluate f of negative 1. Okay. So in this case, we can use our synthetic division. So we're looking at negative 1. So we're going to put negative 1 in the box. And we have x to the 7, 6, 5, 4, 3, 2, 1, and 0. Okay, so we need to evaluate at this point. We bring down the 5. 5 times 1 is negative 5, plus 0 is negative 5. Negative 5 times negative 1 is 5. 5 minus 3 is 2. 2 times negative 1 is negative 2, plus 0 is negative 2. Negative 2 times 1 is 2, plus 0 is 2. 2 times negative 1 is negative 2, plus 2 is 0. 0 times negative 1 is 0, plus 0 is 0, and 0 times negative 1 is 0, plus negative 1 gives me this, right? So this is x to the 6, to the 5, to the 4, to the 3, to the 2, to the 1, my constant, and my remainder, okay? So what that tells me is that f of negative 1 is equal to negative 1. So if I plugged in negative 1 up in here to this equation and simplify it out, then my solution should give me a negative 1. Okay, that's really what the remainder theorem is telling. Okay, question. Okay, couple of more examples. This one is, if you notice, it says show that this is a 0. Well, C is a 0, right? So that's telling me, if it tells me it's a 0, I plug it specifically into the box. If I say it's a factor, then I have to say what makes it a 0, right? So this, let's look over here. This is a factor, therefore this is a 0, okay? So the factor is the x minus c. The 0 is the value of c that makes that true, okay? So in this case, we would put the square root of 5 in the box, and we would have 1, -4, -5, and 20. And just change the color since they're close with that. Okay. Bring this down. That's a 1. So this is square root of 5. So this is -4 plus the square root of 5. Multiply that. So -4 plus the square root of 5 times the square root of 5, right? We have to distribute. So that's -4 square roots of 5 plus the square root of 25, but the square root of 25 is 5. Okay, so let me just make this purple, and I'm going to put negative. I want this to be purple. I want this to be -4 square roots of 5 plus 5. You can see I have a positive 5 and a -5. Those are going to cancel out with each other. That's going to give me a -4 square roots of 5. When I multiply that, I have -4 square roots of 5 times the square root of 5. When I multiply that, I get -4 times the square root of 25, which is -4 times 5, which is 20, -20. And you will see that that gives me a remainder of 0. So no remainder means that the square root of 5 is a 0. Okay? Question. All right, so for this last one on this page, we have polynomials that have that. So we do get into complex numbers, just barely touching on that tonight, or those imaginary numbers, right? And so a complex number is where you just have a plus bi. And if it's a 0, you have to have its conjugate as well, as I was saying. So if you have 1 0, and we're not getting into the conjugates here, but if 8i is a 0, then -8i is also a 0. Okay, but we're not getting that step in this problem. So what we want to do here is we want to determine, or we want to show that 8i is a 0, okay? So we take 8i and we put it in our box, and then we have x cubed, x squared, x, and our constant. Bring our 2 down. 2 times 8 is 16i. Okay, 16i plus 1, so that's 1 plus 16i. You can't mix imaginary, just like you can't mix square roots together with constant. So now we have, let me get another color. Over here, we have 1 plus 16i times 8i. Okay, so that's going to give me 8i plus 8 times 16, which is 128i squared. Remember back from algebra days that I squared is equal to -1. Okay, so this is 8i plus 128 times -1. So this is -128 plus 8i. So this is, or I can leave it in the 8i minus 128. So we have 8i minus 128. So the 128s cancel with each other, and I'm left with 8i. Okay. Then I have 8i times 8i. That's 64i squared, but an I squared is the same as -1, so that's -64. And that gives me a remainder of 0, and therefore, so we have no remainder. So 8i is a 0. Okay, question. Okay, the factor theorem. So this is telling me if we have a polynomial and if I evaluate it at c and it equals 0, then x minus c is a factor. Okay, and if x minus c is a factor, then f of c is equal to 0. Okay, so for this problem, we're trying to determine if x minus -4, right, where c equals -4 is a factor. So I put my c over here, -4, and I have x cubed, squared, to the 1, none. They're all in order, so I could just do 6, 11, -60, -32. Okay, and so let's bring that down. We have 6 times -4 is -24, plus 11 is -13. -13 times -4 is 52, minus 60 is -8. -8 times -4 is 32, minus 32 is 0. You see here I have no remainder. Therefore, x plus 4 is a factor, and -4 is a 0. Okay, so the x plus or minus a value, c, is a factor. Whatever the value of c is a 0. Okay, so that's the terminology difference. Okay, question. All right, just a couple of more examples and I will let you guys go for the evening. We want to factor this problem and we're given that x minus 6 is a factor. So if x minus 6 is a factor, right? So if x minus 6 is a factor, then 6 is a 0. That's what that's saying, okay? So then I know that I could put a 6 over here in this box, and I can see I have 5, 4, 3, 2, 1, 0. So I could just plug 4, negative 24, negative 3, 18, negative 1, 6. That's not enough room. We'll bring the first term down. So 4 times 6 is 24. That gives me minus 24 is 0. 0 times 6 is 0. Minus 3 is negative 3. Negative 3 times 6 is negative 18. Plus 18 is 0. 0 times 6 is 0. Plus negative 1 is negative 1. Negative 1 times 6 is negative 6. Plus 6 is 0. Okay? So if this was x to the 5, so this is x to the 4, x to the 3, x squared, x, my constant, and my remainder. Okay? So a factor here is, excuse me, going to be, we know that x minus 6 is a factor because that's what we're doing here is factoring this problem. And this is 4x to the 4 minus 3x squared minus 1. Okay? And we could factor that further. I will tell you, if you have a squared minus, so this one is really, if you think about this, here's another thing in factoring that you could Google is magic X for factoring, right? And check that out. So, but how do you factor this, right? Well, because that has because you have x to the 4 and x squared, it's really, you could think of it more in terms of, if it was like 4x, it's more like, it could be more like 2x squared, right? That's the same thing that it is, right? Because 2x squared is the same as 4x squared. You can think of that and factor it further. But so this actually simplifies into, you would have 4x squared and an x squared, right? So how do you break that out? And so the magic X will help you come up with a method. Many of you probably already are very familiar with factoring. It's really a prerequisite for this course is being able to factor equations. But if you do need a refresher, you can do magic X, or you can just Google factoring polynomial. Factoring polynomial. Are all good topics to search on. So this would be x squared plus 1, or 4x squared plus 1, and x squared minus 1. So when you factor those back together, if you FOIL them back together, you get back to the original equation. And so we'll bring our x minus 6 here. This one, the 4x squared plus 1, we can't get it any smaller, but I do want to point out that this right here, that is really like a squared minus b squared. That's a perfect square minus a perfect square. And we can factor that as a minus b, a plus b. Okay? And so in this case, that is, I have x squared minus 1 squared. So I could factor this here then as, if this was my a and this was my b, as x minus 1, x plus 1. Okay? And then we have to keep our previous terms as well. So if we were asked to factor this down as much as we could, that is what that would look like. Okay? Question. Okay? So the last topic that we will go over tonight is if I wanted you to write a polynomial of a specific degree and I give you the multiplicities, then we can do that, right? So here I tell you that I have a 0. 2 is a 0 with multiplicity of 2. Well, if 2 is a 0, then x minus 2 is a factor, right? Because what is the value of x to make that a 0, right? So if x is positive 2, then that's a 0. So, and this is with multiplicity of 2. So that is x minus 2 squared because of the multiplicity of 2. Plus, it tells us that x minus 5 is a factor. So the same thought process, right? If negative 5 is a 0, then x minus negative 5 is a factor, which is really what? Just x plus 5. Okay, so x plus 5 is a factor. And now we just need to expand that out because we want a third degree polynomial. So this is x minus 2 times x minus 2 times x plus 5. So when we do FOIL on the first two terms, we end up with x squared minus 4x plus 4 times that x plus 5. We FOIL all of that up and we get x cubed plus x squared minus 16x plus 20. So that would be the polynomial of third degree. So you can see that the leading coefficient has an exponent of 3. And that is what that is looking for. Okay? Question. All right, well, that is all of the new information that I have for you guys today. If you don't have any questions, you're free to go. If you do have questions, I will stick around for as long as you guys need. And then if you want to have a conversation about your specific grade or exam or any personal information, we'll reserve that till everybody leaves the room or all the other general questions have been answered, and then I'll put those people in the lobby and then bring you all back one at a time so you can have those personal conversations. Okay? Any general questions at this time?
Professor, I'm sorry I joined the class late today. How do I get access to the recording of the class?
So you just go in Canvas. You'll go to the link on the far left pane that says Zoom, And one of the tabs at the top says cloud recordings.
All right, thank you.
And it may not be ready until it depends on how long it takes Zoom to process. Because I don't plan on staying up past like 10. So if it isn't available by 10 or 10:30 tonight, I probably won't be able to publish it till tomorrow evening.
Okay, first. Would I find all the recordings in there?
Yes.
All right. So I tried to find the recordings before exam, the previous classes, but I couldn't find it.
Okay, hang on just a second and I can screen share. Let me just open up our Canvas classroom. Just a minute. All right, so here I just came on the left-hand pane to the Zoom, right? And here it says cloud recordings. And so when you click on that, you'll see the previous 2 classes here. So you can
All
see
right.
this from February 5th, and this one was from February 12th.
Thank you.
So I will show one more thing. So when you click on this, it gives you this, right? This is if you want audio only. This is if you want the whole recording. So I think it does audio and both, right? So if you click on this to play, you see how it has like a password pop up there? You want to hit Control V as in Victor. Because what happens is when you come over here in Zoom and you hover over it, when you click on it, it automatically saves this password into your computer's memory. See how if I click on the I, it's like this weird wonky thing. You can either click on this double box that copies it, but also when you push play here, it brings you to this other page and you're like, I don't have a password. But if you just do Control V as in Victor, it'll paste it in there and then you can click watch and watch it. Or you could uncover it and copy it like by clicking on that, or you can type in what it has here. Those are random passwords. I don't create the password, but every single video is going to have a different randomly generated password from Zoom.
Okay. Thank you.
You're welcome. All right. Any other questions? All right, if you guys don't have any questions, you are free to go. And then I will see you all next Monday.
Thank you, Professor. Good night.
Good night.
Good night, Professor.
Good night.